Alright, so welcome to our lecture for methods of separation. So this lecture is going to focus about um, laboratory methods that allow us to separate analytes from certain mixtures. No, um, I'm sure everyone is familiar with what mixtures are, and in that case, we're no longer going to delve or we're not going to go deeper into that topic, but just a certain review. When you say mixtures, so mixtures are substances that have one or more constituents. Okay? We have different kinds of mixtures. You have your homogeneous and you have your heterogeneous. Alright, so homogeneous being mixtures that are particularly dissolved or indistinguishable from each other, while heterogeneous mixtures are mixtures that have clearly or visible or objectively separate parts even though they are mixed together. Okay, so just a quick review of what mixtures are. So homogeneous would we could consider solutions. Okay, solutions can contain many different types of substances, but they are again indistinguishable from each other. So like for example, what we consider or what we drink, coffee, or sometimes Milo or milk or chocolate drinks. Whereas heterogeneous mixtures are mixtures of substances that are clearly separate from each other, although they are together. So that we could consider a class, for example, or a people attending a seminar. Those are heterogeneous mixtures. So people from different backgrounds, different universities, males and females, when they are in one certain room together, that is considered a mixture, but a heterogeneous one, because even though they are mixed in with each other, they are still clearly distinguishable from each other. Okay, so moving on. Next, the first method and probably the most common method of separation inside the laboratory is what you call the centrifugation. Now, as the term suggests, this centrifugation is a process in which centrifugal force is used to separate solid matter from a liquid suspension. So, technically, you have a center which spins rapidly from one side, from counterclockwise or clockwise, it hardly matters. And in doing so, pushes the substances at the bottom. Okay? It pushes the substances towards the outside. So this is particularly useful when separating suspensions. Okay? However, if you're going to be separating a homogeneous mixture, this is not going to be useful because again, these solutions are dissolved into each other and are chemically bonded. So that means that even if you centrifuge the solution for a whole day, you're not going to be able to separate mixtures that are dissolved. So this again is particularly useful in suspensions. You could also use it for colloids, but that is not our application in the laboratory, no? Okay, so centrifugal force is employed. That's why it's called centrifugation. Usually inside the laboratory, we reach until 3,600 RPM. These are rotations per minute, no? 3,600. Or to put it in simpler terms, this is the speed at which the centrifuge spins. Okay? So, again, in the laboratory, this is particularly useful for blood. It's also for urine, for CSF. It can also be useful. Cerebrospinal fluid is the fluid representative or the sample representative of our nervous system. Okay, so among other things. Next is decantation. Now, decantation is also, like centrifugation, quite useful for suspensions, no, or heterogeneous mixture. The decantation is the process of pouring a liquid gently so as not to disturb a solid in the bottom or at the bottom of the container. So what we're going to do, or what decantation actually is that if you have a certain container as such and then you have a suspension, you're going to let gravity do its work. So you're going to allow it to settle. You're going to give it time. And then eventually, it's going to separate. So you have your liquid portion and then you have your solid portion at the bottom. You have your liquid at the top and then you have your solid at the bottom. Okay, so that is decantation. And then after they separate, or after the solid settles at the bottom of your container, you can then gently pour our liquid out of the container. Okay, so you're going to pour the liquid out from the container to produce the separate constituents. No? So the solid portion is going to get left behind in the beaker or your container, and then the liquid portion is going to be transferred or disposed. Okay, so decantation is a step that we can use after centrifugation. Okay, and this is particularly useful in urine. Okay, so after nating mag-centrifuge ng urine, we usually decant our urine. Kasi usually sa urinalysis, just to give you an idea, it goes as your physical, and then chemical, and then microscopic examinations. Okay, so physical muna pertains to the color, probably the consistency of the urine, and the volume. And then you have your chemical, which is concerned with the chemical constituents of the urine. And then after chemical analysis, since hindi na natin kailangan yung physical, yung chemical, we can dispose of the excess. So what we do is we centrifuge the urine, and then eventually, we undergo microscopic analysis doon sa sediments ng urine. Okay, so you might think na yung urine nyo is just purely water or purely liquid, but if you centrifuge your urine, you're going to notice sediments at the bottom. Okay, so magkakaroon tayo ng settled particles doon sa baba. That means that the urine contains certain constituents that are part of the urine and has to be examined through microscopic analysis. Next is filtration. So filtration is another method of separation that we use in place of centrifugation when we have mechanically sensitive particles. Okay? Because centrifugation actually exerts a lot of mechanical stress on our samples, no? So kapag meron tayong samples that are sensitive to mechanical stress, filtration yung ginagamit natin. Okay, but filtration is very slow, no? So when the filter paper is placed inside the funnel, yung setup niya is usually you have a funnel, and then a filter paper is placed to line the funnel. So filter paper siya. Okay? The liquid that passes through the filter paper is called the filtrate. So yung lumalabas daw dito is called the filtrate. Okay? However, this is a relatively slow process, which means it's going to take hours before you finish a batch. So, for example, meron kang 200 ml na kailangan mong i-filter, and then it's particularly viscous. Sabihin, it's not, hindi siya malabnaw. It's going to take you around siguro mga 4 hours, no? Okay? Because of the filter paper is so fine that it only allows the passage of a few minute particles. Okay, so analytical separations. Modern day chemical analysis can involve very complicated material samples. So meaning, kapag meron tayong samples na na-receive, it's not just usually A plus B. Simple lang siya, no? You have two constituents. Usually, yung mga samples na sineseparate natin could be A plus B plus C, plus D pa minsan. So in this case, we make use of analytical separations. So si analytical separations natin is a multi-step separation technique. Okay? Now, meron na tayong naging example ng ating analytical separations kanina. So, what we do with urine is actually, it can be considered as an analytical separation because we perform centrifugation first and then we perform decantation. Okay? So, analytical separations, to make it a lot simpler, are separation techniques that involve multiple techniques, step by step, and eventually we can separate A from B, from C, from D. Okay? However, we also have to, or one of the main reasons we perform separations is because we want to avoid what you call interference. So interference are species other than the analyte. So hindi daw siya analyte that affect the final measurement of our readout device. So ito daw ay kahit anong bagay or kahit anong chemical constituent na hindi yung analyte natin, or rather hindi yung hinahanap natin. These are what you call interferences. Okay, substances other than the analyte generate an instrumental readout similar to the analyte such that the interference adds to the readout of the analyte. So for example, let's try to elaborate on that. This is your readout. Okay, yan daw yung detector nyo. And then you're trying to look for analyte A. Okay, this is your analyte. And then you have, let's say, 3. Just to illustrate the example, 3 analytes of A. Unfortunately, because you've chosen the wrong method of extraction or the wrong method of separation, meron kang nakuhang kamukha ni analyte A. So you got somewhat a triangular analyte, no? Or rather a triangular substance. Excuse me. So ngayon, kapag nag-read out ang ating device, it's going to read 1, 2, 3, and supposedly, dyan na siya titigil. Okay, it's going to stop there. But since you have a substance that looks like your analyte A, it's going to eventually read it out as well. So, ang correct natin is dapat 3 lang yung readout niya. However, since meron siyang kamukha, it reads out 4, which again is incorrect. Okay, so that is one form of interference. Another one is that it can also suppress, ibig sabihin na pipigilan niya yung readout for the analyte. So for example, this is again your readout device and we're still looking for analyte A. Okay? Ngayon, unfortunately, mali yung napili natin na method of separation and we were not able to separate this, or rather a substance that looks like a circle. Excuse me. So in this case, kapag nagre-read out na or kapag nagde-detect na yung detector natin, since our circle is a lot more pronounced, easier to find, it's just going to look for the circle. Okay? So ngayon, ang readout natin is just 1. When supposedly the correct readout is 3. Okay, so mali yung na-readout natin. This time, kulang. Because this time, yung analyte natin, ang ginagawa niya, it suppresses the readout for the analyte. Ito namang nasa taas kanina, if you focus again on the top example, ang analyte naman natin dito, or rather ang interference natin dito, it adds to the readout. Okay? So those are your kinds of interferences. Okay, next. Another method of purification or separation is what you call recrystallization. Okay, so recrystallization is basically what you call, or in simpler terms, evaporation. Evaporation. Okay, so what you do in recrystallization is that you have this kind of solution, liquid, and then you have a dissolved amount of particles or your analytes inside, and you want to separate the liquid from the solid. So you're going to apply heat. By the way, a triangle is heat. Okay? And the liquid is eventually going to evaporate, and then the solids at the bottom are going to recrystallize. Okay? Now, it's called recrystallization because we add another step. Nagdadagdag pa tayo ng isa pang step. In this case, what we're going to do is, for example, you have a solution, A plus B. Maglalagay ka pa ng isang solvent that is more affixed to your analyte A na hinahanap natin. So, ang result niya is that it's going to have a separate solution. For example, yung alcohol, meron ka ditong A, meron ka ditong B. Meron na tayong 2 parts ng liquid. And then you're going to have them evaporate. And then yung vapors niya, i-collect natin. Okay, this is an oversimplification. This is not an actual setup. This is just an oversimplification. Okay, so ang matitira dito is B. And then ang matitira naman dito, or mako-collect natin, is A. And then eventually, we apply heat, which is going to evaporate the liquid portion and going to allow crystal A to form crystals. Okay, so that is recrystallization. Okay, so just additional explanation for recrystallization. Next is distillation. So distillation is a method of purification of liquids contaminated with either dissolved solids or miscible liquids. Okay, this method consists of boiling and evaporating the mixture and recondensing the vapors in a condenser. So it's a different setup. It's a lot more complicated, no? But to put it simpler, in simpler terms, this is evaporation with condensation. Okay? To illustrate this, we have a container. It's going to evaporate. And then yung mga vapors na nag-evaporate, we're going to collect it, pass it through a condenser, and then collect the sample again. Okay, so we're going to apply heat, and then eventually mag-evaporate yung liquid na ayaw natin or gusto natin. It depends on what you're trying to do. And we're going to collect the vapors. It's going to pass to a condenser. Ang purpose ng condenser natin is to cool down the liquid. Okay, so imagine na ito ay parang radiator sa kotse, no? If you're familiar with the term, it keeps the engine cool. So ganun din, no? It's going to collect the vapors. The vapors are going to pass to the condenser. The condenser, which disperses heat, is going to cool the vapors, and it's going to return it to its liquid form. So kapag liquid na yung form niya, it's going to drip down, and then i-collect natin siya. Okay, so that is distillation. Okay, the separation is based on the fact that the contaminants have different, tandaan po this is the principle of distillation, boiling points, and vapor pressures than the liquid to be purified. Now, the substances with lower boiling points and higher vapor pressures are therefore separated from the substances that have high boiling points and low vapor pressure. So, for example, distillation is particularly effective if you're separating liquids that have a great distance in boiling points. So for example, ang mixture mo, meron kang alcohol which has a boiling point of 73 plus minus 1 degrees Celsius, and then you have water which has a boiling point of, alam na nating lahat, 100 degrees Celsius. Okay? So, mas madali siyang i-separate because once you reach the temperature of 73, alcohol is already evaporating. while water is barely boiling, no? It's barely simmering. So, ibig sabihin, mag-evaporate na lahat ng alcohol natin before our water starts evaporating. So, madali silang i-separate. That's the reason why distillation is also commonly used. And probably, naririnig nyo, madalas, no? Distillation is very useful when we are making alcoholic spirits. This is a method of purification for alcoholic spirits. Okay? But it has lots of laboratory applications. Baka isipin nyo yun lang yung application niya. So anyways, distillation again, purpose niya is to purify, separate, mix liquids. But in this case pala, ang kanyang principle is boiling points. Okay? One modification of our distillation is what you call the fractional distillation. So, in this case, meron tayong fractional, no? Si simple distillation kasi, it's only effective in some cases, which were mentioned earlier, no? So, kapag magkalayo yung ating boiling points, pwede tayo mag-simple distillation lang. Number 2, kapag dalawa lang yung mixture natin, pwede tayo mag-simple distillation lang. But if it's a more complex solution, ibig sabihin, mas maraming constituents, and also mas maraming or mas magkakalapit yung boiling points. In that case, pwede na tayong gumamit ng fractional distillation. Okay, so these repeated steps occur in fractional column tube or the fractionating column above the original heated container. So yung setup niya, I'm going to show you, is like this. So same setup lang siya, no, sa ating simple distillation. The only difference is meron ka ng fractionating column. So si fractionating column, ang dagdag lang niya is that you have glass beads. Sometimes it can be cotton as well. But anything with a large surface area, pwede natin siyang gamitin sa fractionating column. Okay, what is the purpose of a fractionating column? So once our solution starts to evaporate, for example, meron kang solution na 73 degrees Celsius ang evaporation or ang boiling point, and then you have another solution that's 76 degrees Celsius. Okay? At a certain point, for example, umabot ka na ng 74 degrees Celsius, you're eventually going to evaporate or start vaporizing both. No? Nag-aano na siya, nag-vaporize na si 73, nag-vaporize na rin si 76. But the thing is, there is more of the 73, mas madami, that is evaporating. And so, your 73 degrees Celsius is going to make it up the fractionating column and into the condenser. Habang si 76, since konti lang siya, it's going to stay in the fractionating column and eventually precipitate down. Babalik lang siya. Okay? But again, there will come a point that your collection is a mix of 73 plus 76. Kaya meron tayong tinatawag na waste container. Which again, ang purpose ng waste container natin is to contain your intermediates or yung mga mixtures natin. Okay? And then after a few drops or after a few minutes, you're going to replace the waste container, papalitan mo siya ng bagong vessel, which is going to collect the purified. It collects the purified extract. Okay, so it's a bit more complex, but again, I would only like you to remember that your fractional distillation is used if there are more complex solutions. Okay? Next is we have extraction. No? Yung mga extraction natin, these are methods of separating the constituents or the chemical constituents or the chemical constituents of a certain analyte. No? So in this case, The sample containing the analyte is a liquid solution, typically a water solution that also contains other solutes. So, meaning, meron tayong solution that is impure. The need for the further separation usually arises from the fact that the other solutes or perhaps the original solvent interfere. So, pinag-usapan natin kanina yung interference. In this case, kaya tayo nagsiseparate ng extract or rather ng analyte from a certain solution is because possibly magkaroon tayo ng interference kapag hindi natin siya sineparate. Okay? Now, this is a method in which the analyte is removed from the original solvent. Take note, meron tayong two parts dito. You have your original solvent and you have your extraction solvent. So, you have your OS and you have your ES. Okay? Ang goal natin is to get our analyte that is mixed with our original solvent to transfer to our extraction solvent. Okay? Again, original solution or the original solvent and your extracting solvent. Now, for this to be successful, the two liquids must be immiscible. Ibig sabihin, yung original solvent natin or yung original solution natin should not mix with your extraction solvent. In that case, forming two layers. Okay? So, dapat daw hindi sila magmi-mix together. It could be your OS, this could be your ES. Okay? Dapat meron silang separation. Next, the analyte must be more soluble in the extracting solvent than the original solvent. Okay, sabi natin dito, yung analyte daw, dapat gusto niyang lumipat kay extraction solvent kaysa magstay kay original solvent. So again, two considerations. Number one, dapat hindi sila nagmi-mix. Number two, magkabaliktad, no? Yung analyte daw natin, mas gusto niyang lumipat kay extracting solvent kaysa magstay kay original solvent. Okay? In other words, or in Tagalog terms, dapat kaya siyang sulutin na extraction solvent. Okay? And this is a specialized glassware called a separatory funnel specifically for liquid-liquid extraction. So, makikita natin, this is what I was illustrating earlier. This could be your extraction solvent, and this one could be your original solvent. It depends, kung ano yung mas dense sa kanilang dalawa. Okay? Again, sabi dito, they are placed together. So, pinagsasama na sila agad with stoppers sa taas and a stopcock sa baba. Once they are both inside our separatory funnel, we shake them vigorously for a moment, and you call it actually as the shaking venting step. Okay? It is repeated several times such that the two liquids have plenty of opportunity for the intimate contact required for the analyte to pass into the extracting solvent to the maximum possible extent. So, maraming beses, usually 3 to 5 times, ginagawa itong shaking venting step. Okay, so this is your shaking venting step. You're going to shake, invert, and then open the stopcock. Okay? Again, shake, invert, and then open the stopcock. We open the stopcock because we have to release air. Kasi this shaking is going to produce air because of the contact. It's releasing some air, some gases, and in that case, kailangan natin silang i-release. Otherwise, the pressure is going to build up inside the separatory funnel, which could cause a disaster. So, kailangan natin siyang i-release. Kaya siya tinawag na shaking, venting. Okay? Following this procedure, after natin siyang i-shake and i-vent, the funnel is positioned in a padded ring, in a ring stand, and left undisturbed for a period of time to allow the two immiscible layers to once again separate. So, ayan, that would be the setup, no? It's going to take around siguro 30 minutes to about 1 hour for it to separate again. Kasi, shake mo nga eh. So, it's going to mix. So, after 30 minutes or 1 hour, eventually, they're going to separate again. Okay, next is solid liquid extraction. This method is used when the analyte needs to be extracted, this time, kanina from a liquid, this time from a solid material. Okay? Rather than a liquid. Okay? The weighed solid sample, preferably finely divided, is brought into contact with the extracting liquid. Now, there's a reason why we have to finely divide our solid samples, no? And that is particularly to increase the surface area. Okay, kasi gusto natin na mas maraming contact yung extracting fluids natin or extracting solvent natin with the solid material. So for us to be able to do that, we increase the surface area by finely dividing the solid. Okay? And then finally, once you increase the surface area, you can finally extract the solvent, no? Or rather the analyte na kailangan natin. Okay? The mixture is shaken or stirred for a period of time again to promote contact. Okay, following the extraction, the undissolved solid material is then filtered out and the filtrate is analyzed. Okay, a good example of this would be coffee brewing. Okay, this is our application in everyday lives, no? Coffee brewing, again, you start with coffee beans. Okay, so pagpasensya na, these are coffee beans. Anong ginagawa natin sa coffee beans bago natin magamit? We grind them. Okay, we finally divide it, no? Ginagrind natin siya. And then eventually, after grinding our coffee beans, we have your coffee grounds. So si coffee grounds naman, for those who are familiar with proper brewing techniques, we weigh it. Diba? Titimbangin muna natin. And then eventually, once we have the proper measurements, we pour in some hot water. In this case, yung solid natin is your coffee bean or your coffee grounds, and then yung extracting solvent natin is hot water. Okay? And aside from that, no, meron pang isa, this a classic Filipino dish, meron nilaga. Nilaga is also an example of a solid liquid extraction because you're extracting the essence of, it's either pork or pwedeng beef kung gusto mo, into the soup. Diba? That's nilaga. That is solid liquid extraction. But again, in the laboratory setting, no, solid liquid extraction is very common in research. Especially for plant-based research. Okay? So that is it for our solid or other methods of separation, no? Concerning our field. Okay, there are lots of other methods of separation, and I'm sure I would like you actually to watch a few videos from YouTube channels that promote analytical separations, no? Or that rather use analytical separations in their methods. Okay, so I guess that's about it. So thank you very much for watching our lecture video, and I hope you learned something new. And then that's it. So thank you and stay safe.